Salam sir, hi sir, I am Syh Agv. So today I'm going to demo my experiment 2, which is pulse width modulations of DC motor acceleration control. Okay, in this experiment, we have to construct our circuit as follow the schematic diagram. So this is my circuit view of my experiment, and I've used Arduino Uno, 9-volt batteries, breadboard, motor drivers, potential meters, multimeter, DC motors, and this is the schematic view of my experiment. So we can see that it is identical with the schematic provided in the lab module. So I've achieved the first step, achieved the second step, and the third steps. Okay, so we have to show our coding. So this is my code. So at first I have to initialize or declare the pin I've used for enable A, input 1, input 2 for the motor drivers. So after that, I have to declare that their pin mode, for example, like pin mode enable A is as output. If I have something as input, I have to declare it as input. So inside this for loop, okay, it's like this. So the port in is the potential input. So it reads the signal whenever I rotate the potential meters. So it will return 1023 at max rotations. So after that, I use these values to convert it into the input voltage so that I can view in my serial monitor like this. Okay, so this is the port in I've mentioned earlier. So the PWM will be converted with the same method, which by using some like ratio calculating method. Okay, so after that, I will print all of the data I achieved. Okay, and then I have to write the pins. So these sections of codes means that my input 1 will be low in conditions and input 2 will be high in conditions. Means I will switch on the input 2 and turn off the input 1. So after that, I will just start the simulation. So copy the coding. Okay, I've copied and okay. So I start the simulation. Initializing. Okay, clear. So we can see that whenever it's at 0, the port in at 0, the voltage input will be 0.00 and the PWM will be 0. And if we max rotate it, it will return 1, 0, 2, 3 as the port in values, and the input voltage will be at 5, which is at max, and the PWM will be 255. So we know that PWM will have a scale at 0 to 255. So whenever we rotate the potential meters, it will be converted into the voltage input, and next will be converted into PWM. So this is how I run my experiment, and so this is the formulas that I convert my PWM from the port in. Okay, so basically this is the simulations, and if I need to show the data, so the input readings, I collect 10 data, which from 0 to okay 0 to 0.5 and to 4.5, which have an increment of 0.5 volt. So for the PWM reading will be as stated in the table. So for example, if I have 500 millivolt, which means 0.5 volt, I will have PWM of 25. If I have 2.5 volt, I will have 127 PWM. So this is the data I collected, and this is the graph. Okay, so we can see that it directly proportional to PWM. And this is the programming code. Yeah. So basically, this is all of my experimentation demo. Thank you, sir. Terima kasih.